Hey, algebra. This is the video for section 9.4, and I'm going to do this one a little bit differently. We're only going to do part of this section. We're going to kind of skip the circular part of this, and we're only going to talk about periodic functions in this section. So I'm going to skip around and skip a couple of examples. But the first thing that I want to start out doing in chapter 9, we've talked about trig functions, so like sine, cosine, and tangent. And now we're going to talk just a little bit about what their graphs look like. Okay, so let's kind of review. In algebra, basically the main thing that I want you guys to get out of algebra is the different type of functions that we deal with and what they look like when you graph them. So a linear function, and I know we go through this all the time, a linear function or a function like y equals x, okay? What will he look like when you graph him, okay? He will look like a straight line. Now he may be slanted a little bit more or flattened out or whatever, but he will look like a line, okay? A quadratic function, think about what that one looks like. Quadratic, or y equals x squared. He will be a function that looks like a parabola. All right, let's do a couple more of these. A cubic function, y equals x cubed, is going to look like, I need Marcus here to tell me what that thing is called again. I forget if it was a squiggle or whatever it was, okay? That's what x cubed will look like, okay? Y equals x to the fourth power is a quartic function. And he will be something like a W. Okay, so maybe something like this. I don't remember which one was a squiggy and which one was a hump or whatever it was that you guys called it, okay? We could do a quintic function. Yeah, let's go ahead and do quintic function. X to the fifth power is quintic. And he will look like one of these, okay? And then let's go to like y equals the absolute value of x, okay? And think about what he looks like when you graph him, okay? So if I graph him, he is going to be a perfect V, okay? And keep in mind that as you're going through here, these are just the root functions or the parent functions, okay? You guys have a sheet that has a list of all the parent functions. And so what I mean by parent functions is when you put numbers in here, so maybe instead of having just x squared, you would have like 2x squared, okay? That's going to change him and make him taller, or like shifting him up and down and that type of thing. So this is just what the parent looks like, okay? So absolute value looks like that guy. There's a couple more that we know. So we know what the square root of x looks like. We know what the cubic root of x looks like. And we know what an exponential function looks like let's say 2 to the x power is an exponential function. Okay, so let's do those. Okay, the square root, the cubic root, and an exponential function. Okay, square root is going to start here and go forever that way. Okay, he doesn't go past this way because you cannot have a negative inside of a square root. If you have a cubic root, you can, so he goes that direction. An exponential function is going to go like this. If it's a growth, if it's a decay, it's going to go the other direction. So I'll maybe put that in here. It's going to look like that as a decay function. So stuff like that, that might be pretty close to the end of the list. But now we're going to talk about periodic functions. And two of the main periodic functions that we're going to deal with is y equals sine of x and y equals cosine of x. Okay, I'm not going to talk too much about tangent, what his function looks like, because he is really weird. But sine of x starts here. This is what sine of x looks like. And he does one of these. Okay, he is like a wave, and he'll, of course, keep going on forever, and he'll go forever this direction as well. You know, that's what the graph of sine will look like. Cosine will be kind of the same thing, except he'll start up here, go down, and come back up again. So it will still look like a wave, like what sine does, except he starts up here at 1, where sine starts down here at 0. So that's the difference between cosine and sine. They're both going to be periodic waves, okay? So if we kind of look at a period, like a period of sine will be like this chunk right here. So if you think about like this is temperature or like hours of daylight, maybe these are the hours that the sun is out, then here's the hours that the sun is gone, okay? Then it starts back over again. So sunlight, darkness, okay? Same thing with cosine, his period, if you go from here to here, that's where his block will start and stop, okay? So kind of the same type of deal, except he's just shifted over a little bit further. But these are both going to be periodic functions because they have a set period and then they start back over again. Okay, so like daytime, nighttime, daytime, nighttime, daytime, nighttime. It's going to go on forever. Okay. So sine and cosine is kind of leading us into periodic functions. We're not going to talk too much about what those periodic functions look like. We're just going to discuss periodic functions in general. So I want us to skip down. We're not going to do example 1. We're going to skip over that one, but we're going to go down to this periodic function. Has y values that repeat at regular intervals. One complete pattern is a cycle, and that horizontal length is called a period. So basically what we're doing with this first thing is we're trying to figure out how long his period is, okay? So basically we're starting here, where or how far do I have to go in order for him to get back to that same spot again, okay? Or like if I section him off, this would be one full cycle, okay? This little V part right here. And that one full cycle, if I look at my x-axis here, is 360 degrees. So one full period must be 360 degrees until I get back to where I started from. Which kind of makes sense. I guess if you're facing forward, you would have to turn all the way around in order to get back to where you started from. Then you could keep spinning around again and spinning around again and spinning around again, but it would take 360 degrees to make one full cycle, okay? So example 2, determine the period of the function. They want us to figure out how wide that section has to be in order for him to start back over again. So I look at where he starts. He starts up here at 1, okay? And how far do I have to go before he gets back up to 1 again? So he's going down, over, he's coming back up, and now he's back here again, and then he starts that back over again, okay? So basically, I can chunk this off and say that this is one full period, and then basically we've like hit copy, paste, copy, paste, copy, paste over and over again to get that same picture going on here, okay? Now, how wide is it from here to here? Look at your x-axis, okay? How wide is that? That's going to be a distance from 0 to pi, okay? So the period here is going to be pi. That's how wide that one cycle is, okay? So not terribly difficult. They're going to ask us a story problem in this next one that kind of has to deal with, I don't know if we're on a roller coaster or a bicycle, okay? The pedals on a bicycle rotate as the bike is being ridden. The height of the pedal is a function of time as shown in the figure. Notice that the pedal makes one complete rotation every 2 seconds, okay? So if you see up here, 0 seconds, it's starting up here at the top. At a half of a second, it's over here at the right, at the left side. At 1 second, it's down here at the bottom, and then it's back up to the top, or back up to the right side at 1.5 seconds, and then back up to 2. So it makes 2 full seconds. Okay, so they want us to make a table showing the height of the bicycle. So I'm going to start at height, or at a time of 0. At a time of 0, the pedal is up here, which they have labeled as 18 inches from the ground. Okay, so 18 inches is where my pedal is going to be. Okay, and then at 0.5 seconds, let me just label these in here. 1 second, at 1.5 seconds, at 2 seconds, 2.5 seconds, and 3 seconds. They want us to do all of those. Okay. So at 0.5 seconds, we're down here, the pedal is down here, and that is labeled at 11 inches. Okay, so it's 11 inches down here. Then we go down to 1 second, okay, and after 1 second, the pedal is down here at 4 inches above the ground. I don't know if we're on like a stationary bike or something that we're not touching the ground exactly, but whatever. At 1.5 seconds, we're back up here, which is 11 inches off the ground again, okay, and at 2 seconds, we're back up here to the top. Okay, which is 18 inches above the ground. Then if we go 2.5 seconds, okay, that would be over here. 2.5 seconds would be at the 11-inch mark again. 3 seconds would be down here at the 4-inch mark again. And we would just keep going on forever if we want to do 3.5 inches, 4 inches, etc., right? Okay, so that's what my table is going to look like. Now, identify the period of this function. I'm going to go ahead and do part C before we do part B. Let's graph the function, okay? So at 0, we are at 18 inches, which is about, I don't know, up there somewhere, okay? At 0.5, we're at 11 inches, which is here. At 1, we are at 4 inches, so down here. At 1.5, we're back up at 11, we're there. And at 2, we are at 18 inches. And then we do the process over again, so 2.5 is going to be at 11 inches, 3 is going to be at 4 inches. So this is kind of what he looks like. He's doing one of these cycles, which kind of looks like the sine and cosine, okay? So basically, this is the graph of our function. Let the horizontal axis represent time. That's how they labeled it. And the vertical axis represent the height. Okay, so that's what he's going to look like. They want us to identify the period of the function. So he's starting here at 18 inches, right? 18 inches off the ground. And then how long does it take before I get back up to 18 inches? And then he starts to repeat that process again. Okay, so if I section him off here, you can kind of see that this chunk right here, I could transpose him or copy paste him over and he would end up being the same section, right? Like this section is the same as that one, okay? So then the period marks how long that is, okay? So how long is it from 0 to 2, or from 0 to 2 is going to be 2 seconds. Okay, that's what my period is going to be from there to there. Okay, so that's just kind of what they're asking. They're getting us used to periodic functions. They go down here into this part, and they start to talk about sine and cosine. Those graphs again that I showed you on that other sheet. We're not going to do example 4. But just getting your feet kind of wet with periodic functions when we get into trigonometry class 2 years from now. For some of you, we start to study those a little bit more in depth. But just noting that a periodic function or the graph of sine and cosine, are used to represent things just like these guys are. Okay, so that should be kind of in your toolkit of functions that you know, or kind of know or are used to, and somewhere down the line we'll get back into those, and you'll say, oh yeah, I remember what that kind of looks like. Okay, so kind of add that to your toolbox, and we're not going to do anything else in section 9.4, and really this is going to be the last part of the chapter. Tomorrow I will post kind of a review section for you, or some review exercises to go through, and that'll be like on a Google form or something like that. Okay, so I will have you do that. I'm also going to ask a question at the end of this video, because I think we're at the last bit of the notes that I've given you before school got out. So if you're one of those people who has to have those physical notes, I'm going to go into school tomorrow, and I'm going to run copies off of the next section or the next chapter that we're going to do. And then you guys can come and pick those up at the school, or we can figure out how to get those to you somehow. So answer the question that I have next, and we'll figure out how to get those notes to you. Okay?